couple of pages are just some practice free response questions doing different things. Okay? So, cool. Let's take, you think 48 seems like a reasonable time to be back? 48? All right. Approximately 3.5% of all children born in a certain region are... this might feel familiar. Does this feel familiar? Have I given you guys this one before?
I would have given us something similar.
Okay. I'm shocked I wouldn't have given you guys this one already, but that's cool. We'll talk it all the way through. It's even better if I haven't given it to you yet, right? Okay. Approximately 3.5% of all children born from a certain region are from multiple births. Of the children born in the region from multiple births. So some of the things, as we go through this one, I kind of want to give you guys strategies, right? So as I read... the probability, approximately 3.5% of all the children born in the region are from multiple births. Maybe the first thing I'm going to write down, just kind of for the back of my head, is that the probability for multiple births is equal to 0.035. Does that make sense? And then of the children who are born from multiple births. So, like, the minute I read that, I know that the next probability is going to be given that they came from a multiple birth, because it's only out of those multiple birth kids. Okay? And as we all know, twins, or triplets, I guess, but twins are superior species. Right, Felix? For sure. For sure. Okay? Of course. And so 22% are left-handed. So that 22% is the probability of lefty given multiple births. Are you lefty? Me neither. Of the children born in the region who are from single births. And instead of writing single, do you guys mind if I say not multiple? Okay, just because I think it makes more sense out of this. 11% are lefty. Okay. Now, when I look at this question, like, what makes this a challenging question, are you guys with me? There's a lot of information up there. Okay? And so, the minute pieces of my information are these conditional probabilities, that is usually what tells me I want to build a tree diagram. Okay? Because, like, as we think this through, and that's why I think sometimes writing down and decoding what we've been given is an important idea. Okay? So the question is, what is the probability somebody is lefty? Well, what we're going to do to answer that question is, well, the probability depends on whether or not that person was from a multiple birth or not. Well, we know this one is 0.035. So what does that make not multiple birth?
0.965.
0.965, great. All right, so let's go ahead and assume that someone was from a multiple birth. The next opportunity for them is, are they lefty or not? Well, the probability, you know what, guys? I feel like we helped ourselves out here because we know what's the probability of left-handed one from a multiple birth. So this now becomes 0.22. Everybody good? And what does that leave the probability they're not lefty? Just in case we'll need it. 0.78, I agree. And if I go down here, what if they're not from a multiple birth? Do I know the probability they're left-handed? 0.11. Leaving the probability they are not left-handed, so they're righties, or they're ambidextrous, is 0.89. All right, now, the question is, what is the probability of left-handed? So what should I do? Are you guys with me that it's equal to this branch and this branch? Those are the two. So to find those probabilities, I would do 0.035 times 0.22 plus 0.965 times 0.11. I don't remember the answer. I sure would love anybody with a calculator who's smarter than me to help me through this question. Cool. What do you guys think so far? If you know that you're supposed to do a tree diagram, it's easy. But like the hard part is picking which strategy to use. Like in my opinion, any given strategy, not that bad. It's picking which strategy, it's knowing which one to use is the hard part. Okay, so again, I'm just going to reiterate, how do I know that the tree diagram is what I wanted to build here? To me, the one that makes that obvious is the fact that two of the probabilities we were given in the problem were those conditional ones. Like it told me the second branch for each one of these. You guys with me? Okay. All right, now let's look at part B next. Part B says, what is the probability that a randomly selected child is from a multiple birth given that they're left-handed? Is M given L the same thing as L given M? No, we can't just like do that, okay? So, man, what do we do? We got to pick a strategy. Anybody got any ideas of a strategy we might want to use? You have any resource you want? You know what I would do next? On our formula sheet is going to say the probability of A given B is equal to the probability of A and B over the probability of B. And then the next thing I would do is find the probability, I would change this just in symbols. So that means we would do the probability of M and L over the probability of L. All right, now, what is the probability of M and L? I start here, and if it's M and L, I want to go through the entire branch. So first, what's the probability of M times the probability of L? So what would just this value right up here be? Okay, for those of you at home watching, and follow this branch, So really when I say the probability, we're looking for that. M and L describes the top branch. And what do we do with those probabilities, y'all? We multiply them. And I think it's 0.077, but I'm really not trusting my arithmetic skills today. Is it 0.077? 0.0077, yeah? See, I told you not to trust my arithmetic skills today, guys. All right. Divided by Do we know the probability of L?
It's what we solved for A.
Yeah, you just use your answer for A. From A, that was what we found in A. You just use that. And guess what? If you got A wrong, but you used it correctly here, you'd still get full credit. I don't know the answer. It's relatively low, I would think. Maybe not. 7%, 8%? 6%.
0.068.
0.068. Still doing okay? All right, let's look at part C. Such a good question. How is this getting a little bit more complicated? Which it definitely is, yeah. This tree diagram is describing one baby. This question is about 20. So are you guys with me? That is 20 babies is more complicated than one baby in lots of different ways, to be fair. Okay? So and so the basic premise is now we have 20 and we want to find what is the probability that we have 3 or more lefties. Is everybody with me? And we already figured out that the probability of being left-handed is 0.1138. Hold on. All of a sudden, when I see this makes me think it's binomial or geometric, one of the two. Do we have a set number of trials? Because that's how we decide between binomial versus geometric. And this is a set number of trials, 20. And this X stands for a number of successes. Everybody good? Okay, so once we get to here, we can go and just use our calculator to get there. You're going to pick binomial in your calculator, so whatever you pick, you want to me. And at this point, you're really not pointing it out to me. You can't assume that the person who's reading your work is as smart as I am. Because they're probably smarter. Okay, but they definitely don't know you. They don't know you from any other random kid that they're reading their test. So this is where that idea of communication becomes really important. All right, you guys. Binom CDF, which is what we're going to use, does not do less than or equal to, so we have to do something, we have to do that 1 minus thing, okay? You guys, which outcomes are not greater than or equal to 3? 2, 1, and 0. So we're going to find the 1 minus the probability x is less than or equal to 2. Again, stating that we use the binomial distribution, stating that we're doing the 1 minus. And I don't know the answer. It is more complicated than I know how to do in my head. What are we getting? When it's asking you for P, you're going to put the 0.1138.
597.
Before or after you subtracted?
Before.
Okay, so 1 minus 0.597, which means 0.403, give or take. Does that feel about right? All right. I would like you guys to try A and B only and see how you do on this one.
Do you have a text that I can borrow?
Okay, so you guys, I gave this question on either a test or a final. I've given this question on something before, and many students received a P on part A. Because you know what they wrote? 0.85. They didn't show any work. You guys with me? All right. And same with part B. So what they were expected is that the expected value of ATMs that are open, no matter what variable you used here, you should have done 0 times 0.15. Yes, you need to include that. And if you didn't show this work, you got a P on this section as well. And what did we get for that?
1.73.
And if you rounded that to 2, they docked you points. You got a P again. Okay? Because the expected count doesn't need to be a whole number. It can be a, you know. Yeah.
For A, my work would be 1 minus 0.15.
Say that one more time. Yes, yeah, for sure. Okay. What do you guys think we should do for part C? Bless you. All right, now, you guys, how do you feel about my decoding of what this is asking us to do? Is everybody good so far? All right. Now, because this is where, when I gave this question, people did pretty well in part A and part B other than showing work, to be honest, or rounding their answers. Okay? Then this is where the rails came off the cart. Okay? So, I want to go back to this formula on your formula sheet where given B, and then the bottom of our fraction is B. Is everybody with me so far? So as I'm going through, and I'm given that A is greater than or equal to 1, the bottom of my fraction needs to be 0.85. Because that's the probability X is greater than or equal to 1. All right. What should the top be? Are you with me that 3 and greater than or equal to 1 is equivalent to 3? Okay. So 0.24? What are we getting?
0.2823.
So it went up a little bit, huh? The probability of, is anybody shocked to know that if you know that essentially the probability of having 3 open goes up if you know at least one of them is open? Does that make sense in our heads? Okay. Now, Part D, given that at least one ATM is working when the mall opens, would the expected value be higher or lower than if we weren't given, essentially? Because in Part A, or in Part B, our expected count was 1.73. That included that none of them were working, yes? What it took... So there were 2 approaches you could take to answering Part D, okay? You could write it out in narrative form, or you could keep going and calculate the new expected value, right? So, because we already just kind of said if it's, if you're given that at least one, your table switches to this, yeah? There's no 0 column. And we already figured out that this one was 0.283. That's what we figured out in Part C. Do you guys get what I'm saying here? Okay. And so could we find those other 2 probabilities? Well, to find this one, we just took the original probability divided by 0.85. And the original probability divided by 0.85. Like, we would just have to do that. So I'm thinking this one might be like 0.48, 0.49, something like that.
0.47.
0.47. Okay, and so that one's 75. So this is roughly 0.25, I would think.
Yeah.
Is it exact?
It's 0.247.
247, great. All right. And if I asked you what is the new expected value, I'm going to call this X instead of A this time or whatever. And you could do 1 times 0.1 times, oh my goodness gracious. The same thing we did up top. Get that new expected value and say, hey, that's higher than 1.73. And it will be higher than 1.73. And that shouldn't be that surprising.
What if you just like said it was like you didn't do like the work or that, you just said it was gonna be bigger than that? You could try to like explain it. But
Yes, if you had to do it in narrative form, this is what you had to say. Because I know this rubric inside and out because I've graded this question so many times. It would go up because not only are you erasing the lowest possible outcome, but all of the other ones would go up proportionally. And if you didn't say proportionally, you got into some trouble. So it'd be really hard to do what happened is a lot of people said, oh, because you're no longer including 0, the average would go up. And
you
that's,
still get like a P if you said that.
yeah. All right, let's turn. I might want to point page. Ooh, this is a good one. I think I would like you to do parts A and B on your own. Did you guys get 0.028? Everybody good so far?
I got 0.025.
Did you use 10 or 10.5 as your...
Let me check.
Like, double check that you just, everything was entered in correctly.
I used 10.5. But I actually used 40.5 to not normal. 40.5.
Yeah, that'll do it. Okay. Everybody good so far? And then did you do part B already? Which theoretically you wouldn't have to do any calculation for, though I would, okay? It's saying choose 3 days at random. Can you guys understand, for example, why you might want to choose 3 days at random rather than looking at one specific day? For example, what if the 1 day at random had been senior skip day? Grandview loses funding. You guys catch my drift on that? Okay, so if we pick 3 random days and find the average of those 3, that could help account for some of that. Okay, so so essentially this is asking, will the probability of X bar being greater than 140, how will that compare to the probability of A being greater than 140? Do you guys catch my drift on this? Okay. And so kind of like, here's what you had to say. The standard deviation of the X bars will be smaller than the probability of just any one day. Therefore, 140 is going to feel further from that mean because 140, while is still 20 from the mean, 20 is a different number of standard deviations away. In my opinion, the easier way to do this was to do the calculation where you use 120. Well, what happens to our standard deviation if we're doing means? Well, all of a sudden you're going to take that 10.5 divided by the square root of 3, by the square root of the sample size. And this is this is chapter 5 essentially, or unit 5, where it was like things needed to get, we're using a sampling distribution to answer the question instead. And so I can go up to my previous probability, and all I'm going to do is change that 10.5 and divide by the square root of 3 on it. And now the probability of one being more than 140 has gone down significantly. Because it's way less likely that you get a sample mean of 140 than getting a singular sample of 140. Okay, and part C. A typical high school week consists of the days Monday, Tuesday, Wednesday, Thursday. The principal at one of the high schools believes that the number of absences tends to be greater on Mondays and Fridays. There is a concern that the school will lose funding if the attendance count occurs on Monday or Friday. Which makes sense, right? If one school is chosen at random from each of 3 typical school weeks, or if one day is, what is the probability that none of the 3 days is a Tuesday, Wednesday, Thursday? So for that first week, what's the probability of not Tuesday, Wednesday, Thursday? It's 2 out of 5, yeah? What's the probability the second day is not a Tuesday, Wednesday, Thursday? For the second week? And all you're going to do is multiply that 3 different times. First, it's got to happen on the first week. Another way of thinking of it is for the first week, you have Monday, Friday, or Tuesday, Wednesday, Thursday. And then for the second week, you have Monday, Friday, Tuesday, Wednesday, Thursday. You guys catch my drift here? Like that tree diagram would get multiplied across. But you just do 2/5 times 2/5 times 2/5. All right. Nico, can I talk to you for just 2 seconds? You're not in trouble at all. I just want to talk to you about the AP exam. You have to show up like 5 minutes earlier. So you need to go on Thursday for the AP exam. You're going to need to go to the media center at 11:40 because they're going to take you to a different room for your extra time. Okay? So when I announced to everybody else on 11:40 or 11:45 for you, and you and Matt Sanzo are both getting extended time. You guys will be at 11:40 instead of 11:45, okay?
Thank you.
Thanks.
Thanks, Master.
Have a good one.